Greetings and welcome to Chapter 9, Hypothesis Testing with One Sample. Before we start the actual lesson, I just want to give you a little word of warning. The next couple of lessons that you're going to go through are the groundwork of what you're going to need the skills to be able to do what's called hypothesis testing. Really focus in on this lesson as to how English is translated over to math and what that means in terms of the stats behind the scenes. So lesson 9.1, null and alternative hypotheses. Get to know the new terminology for this lesson. Click on each of the words, learn its definition and meaning. When you are ready, click continue. All right, let me first say that what you've done in the past couple of chapters are really the workup to this point in the class, which is hypothesis testing. Hypothesis is a big word just that means a claim. A claim can be anything. It could be, hey, my car gets 50 miles to the gallon. My claim could be that I'm 6 foot tall. My claim could be that the sky is purple. That's just a claim. My claim doesn't have to be true. It doesn't have to be false. It is just a claim. Now, how hypothesis testing works is that you set up two contradictory hypotheses. So let's take the sky is purple claim. I'm going to say the sky is purple is one hypothesis. My contradictory hypothesis would be the sky is not purple. Right? Either the sky is purple or it's not purple. I'm not going to test to see if it's blue or green or red. Since my claim is that it's purple, the absolute contradictory statement is it's not purple. Once we set up our hypotheses, we then collect data. We go out and we test the sky for its color spectrum. And we collect that data and we determine the correct type of distribution because we're going to run a test on it. Once we run the test, we analyze those calculations and we decide to either reject or fail to reject what's called the null hypothesis. We'll talk about that in just a second. And then we make a decision about our test along with our claim, and we write a meaningful conclusion. So the primary steps in hypothesis testing is to set up your contradictory hypotheses, collect your data, determine what type of distribution it is so you know what the right test is to perform, run the test, reject or fail to reject the null hypotheses, and make a decision regarding your test and your claim. That's what hypothesis testing is. The two contradictory hypotheses are called the null and the alternative. The null hypothesis is generally notated with an H with a subscript of a 0, and we'll call this H sub 0, H0, H naught, or H null. We'll call it by several names, and occasionally I'll just say H0 or H null. But the null hypothesis is a statistical hypothesis that must contain a statement of equality, meaning that it has equal, or it could be a greater than or equal to, or a less than or equal to. So it's one of those three things. The alternative hypothesis is noted as H with a subscript of an A. Sometimes you'll also see this as H with a subscript of 1, but I'm going to keep with the subscript of A. The alternative hypothesis is a claim about the population that's contradictory to H0. And if H0 contains equality, then HA does not contain equality. So the symbols we're going to use here are either the not equal, the strictly greater than, or the strictly less than. Now that's just your hypotheses. Your claim itself can either be an H0 or an HA depending on the language used in the description of the problem. But we will only ever run our hypothesis testing on the null hypotheses. We never test the alternative. Even if our claim is the alternative, we will never test an HA. We will only ever test an H0. Language is going to play an integral part to hypothesis testing. So let's take a look at some wording, and then let's translate that over to a math symbol. And then let's also figure out what would be the claim if our problem description had that particular wording in it. So let's take these one at a time. The wording is the same. So somewhere in the problem, when you're reading the description, you hear the same. The same means equal, and therefore the math symbol is equal. And because it's equal, that must be an H0. Anytime that it contains something about equality, the claim has got to be an H0. What about is different? Well, is different means not the same. And if it's not the same, then it's not equal. And because that does not contain equality, the claim has got to be an HA. What about the wording, there is no difference? Well, there is no difference. So think about this. There is no difference regarding their heights. Well, that means they're the same height. And well, the same means equal. And therefore equal is an H0 claim. Is. It is this. It is 3. It is 10. Well, that means equal. And therefore, if it's equal, it's got to be an H0. Is not. If the language is not, well, that's just the opposite of being an is, and therefore it's not equal. And therefore your claim is an HA. At most. Let's say the baby is at most 6 months old. Now, these next words can be a little bit tricky, but at most, if the baby is at most 6 months old, then it could be 0 months, 1 month, 2 months, 3 months, 4 months, 5 months, or 6 months. That 6 months is included. And therefore, if the baby is at most 6 months, that means in math, it's less than or equal to 6 months. And because it's less than or equal, that does contain equality, and therefore your claim is an H0. At least. The TV is at least 5 years old. Well, if it's at least 5 years old, then it could be 5, it could be 6, it could be 7 years old, and so on and so forth. And if it could be that 5, that means 5 is included. And therefore, 5 or greater than, so greater than or equal to 5. And because it contains equal, the claim would be an H0. Fewer than. You can also word it as less than. Well, it kind of gives it away. If it's fewer than 3. I have fewer than $3 in my pocket. Well, that doesn't mean I have 3 because I have fewer than 3. So it must be less than. And less than is a nice symbol in math, and therefore it's strictly less than, and therefore our claim is an HA. More than or greater than. Well, more than 5 or more than 10. That means it doesn't include 10. It's strictly more than 10. And if it's more than, then it's only the symbol more than. and it does not contain equality, and therefore it's an HA. Under. He is under 7 feet tall. Under. Well, if he is under 7 feet tall, then he's not 7 feet tall. He's less than 7 feet tall, and less than is a math symbol, and therefore the claim must be an HA. Over. There is over $1,000 in damage. Over. Well, it's not $1,000. It doesn't equal $1,000. It's over that amount, and therefore it's more than $1,000 worth of damage, and therefore it's an HA. So really concentrate on the wording and translating that into math, and then writing the corresponding claim. I'm throwing around a couple of words that I'm kind of using interchangeably, but they're not quite interchangeable. A claim could be an H0 or an HA, as we saw. A hypothesis is the mathematical statements that go along with being an H0 and the alternative, or if your claim is an alternative, going along with its contradiction of an H0. So a claim is one of those hypotheses, but the hypotheses always come in a pair, an H0, an HA. We will always test the H0 no matter if it is the original claim or not. It doesn't matter if H0 is the claim or not. We will only ever test an H0. The test results that go along with H0 are either a reject or fail to reject, also known as decline to reject, but I prefer fail to reject. So we either reject or fail to reject the H0. Our decision is based on the results of the test, but it's worded in terms of the claim. And I'll get more into that later on, but keep these things in mind. The hypotheses always come in a pair, H0, H null. The claim is one of those. We only test H0. The test results are either a reject or fail to reject. And our decision is based with the test results in mind, but is worded in terms of our original claim. So how do we write the hypotheses using mathematical statements? So let's talk about statements posed from the H0 point of view and the HA point of view. And these can either be statements about the mean or a proportion. I'm going to focus in on mean, but if we were dealing with proportion problem, then you can exchange the mean for proportion, and it would be exactly the same. The symbol might be a little bit different in terms of instead of a mu, we would use a p for proportion, but all the rest of it is the same. So let's take a statement like for H0, the mean is greater than or equal to k. The HA statement would be the mean is less than k. If the H0 statement is the mean is at least k, then the corresponding statement for HA would be the mean is below k. And I'll do one more. If the statement of H0 is the mean is not less than k, then the corresponding HA statement would be the mean is fewer than k. And there are lots and lots of other pairings of these. The meat of the problem is the mathematical statements. You never will have an H0 without an HA. You will never have an H0 without some equality in it. So our H0 will be mu is greater than or equal to k. Our contradictory statement for HA will be mu is strictly less than k. Remember, HA never has equality. Only H0 has any equality in it. Now let's take another couple of examples. I won't read them all. I'll let you go through them. Let's say our statement for H0 is the mean is at most K, and the corresponding HA statement might be the mean is above K. Maybe the statement for H0 is the mean is not more than K, and therefore the statement for HA would be the mean is more than K. For H0, if you are talking about at most K or not more than K, that is a less than or equal to. And therefore H0 is the mu is less than or equal to K. And the contradictory statement for HA will be mu is strictly greater than K. Let me run through one more set. The statement for H0, the mean is equal to K. Well, the corresponding HA would be the mean is not equal to K. For H0, the mean is K. The statement for HA, the mean is different from K. And I'll let you read the rest. The mathematical statements would be our H0 would be mu equals K. Our contradictory HA statement would be mu does not equal K. So you can see these are the only three options, the only three pairings we have for our mathematical statements. We won't have any others. It's only these three, and it's based on the language in the problem description. Let's look at a few examples. We want to test whether the mean GPA of students in American colleges is different from 2.0 out of 4.0. State the null and alternative hypotheses, and we want to identify our original claim. Now we're looking for our special language. We want to test whether mean GPA of American colleges is different from. So is different from is our special language that we're looking for to help us figure out what symbols we're going to use. Is different from is just a different wording to say not the same. So if it is not the same, it is not equal. And if it is not equal, that doesn't involve equality, and therefore our claim is an HA. It doesn't mean that we get to ignore H0. We have to figure out both of our hypotheses. So we know what our symbol is for HA, not equal to. The opposite symbol of that is equal to. So the H0 is going to have equal to. We're talking about the mean GPA. So we are talking about mu. And what is the mean GPA is different from 2.0. So putting all of those clues together, we get H0 is mu equals 2.0. HA is mu does not equal 2.0. And in fact, HA is our claim. Okay, so just out of the problem, we got all of that. Let's try another one. We want to test whether the mean height of 8th graders is 66 inches. We want to state the null, the alternative, and identify the original claim. So if it means the mean height of 8th graders is 66, is another way of saying equals 66. So the mean equals 66. In other words, mu equals 66. Anytime we have just a flat out equal, that is an H0. Our alternative will be not equal to. So H0, mu equals 66. HA, mu does not equal 66. And because is the word that we're looking at, our claim is an H0. In an issue of U.S. News and World Report, an article on school standards stated that about half of all students in France, Germany, and Israel take advanced placement exams and a third pass. The same article stated that 6.6% of U.S. students take advanced placement exams and 4.4% pass. Test if the percentage of U.S. students who take advanced placement exam is more than 6.6%. State the null and alternative hypotheses. And we also want to point out the claim. Because we're dealing with percentages, we're not going to use mu this time. We're going to use p for proportion. Our keywords, there was a lot of blah, 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 blah. If you go to the very last, second to the last sentence, you see test if the percentage of U.S. students who take the advancement placement test is more than. That's our claim. Is more than. Is more than is strictly greater than, and that's an HA. So we know our HA is P is greater than 0.066. Now our H0 has to be the complete opposite of greater than. And therefore its symbol will be less than or equal to. So our H0 is P is less than or equal to 0.066. Our HA is P is greater than 0.066, and our claim is an HA. You've reached the end of this lesson.